Hey guys, Miss Duncan here. This is going to be a video about our next unit, and this is actually a really short unit. It's really only going to be this week. It's about functions, and a lot of the stuff that we're doing today, it's stuff you've done before. We're just using new vocabulary and using it in different ways. So most of the math today shouldn't be too much. We are going to be talking about what functions are. We've talked about this a little bit in class, but we'll get into specifics about what we mean when we say a function. I apologize, my cat's tail is getting in the way. We're also going to talk about how to solve functions and finding and checking inverse functions, which is a cool way of looking at what would happen for a function that had opposite x and y values. So that is the plan for this video. All right, kind of get this cat out of the way. All right, so a function is a relationship where every x can only have one y that it matches up with. And this is important because it helps us have a more defined and predictable situation. We always know what the outcome will be. We always know if we have one input, one thing that we're doing, there's always going to be an output that matches with that. It's like the idea of cause and effect. So we've talked about that probably in your science classes. One thing leads to another thing. So we have some little images here, and we're looking at functions and not functions. So here's our x's, here's our y's. In this case, 1 leads to 4. So the x has just one y that goes with it. So that is a function. In this case, 1 leads to 4. 2 also leads to 4. And that's fine because I know what happens when I am at 1. 1 gets me 4. I also know what happens at 2. 2 gets me 4. And so we can write those as data points here. Got this thing. So in this one, we have 1, 4 is a data point. And that's okay because the x has a y that it matches. Here, same thing. What we'll have is we'll have 1, 4, but we'll also have 2, 4. And that's okay. Because again, for this x, we know what the y will be. The issues come when you have an x, but you have multiple y's that go with it. So that becomes more like statistics. You don't know what the solution will be. What's the chance of it being 1 versus what's the chance of it being another? That gets into another area of math. And so those would not be functions. So here we see that 1 goes to 4, but also 1 goes to 5. So I don't know if when I have an input of 1, it'll give me 5 or it'll give me 4. Things like that can mess up computer systems. It can mess up, scientific theories. Like, you want to make sure that you know what happens when you do this. What's the solution always going to be? We don't want to be making guessing games when it comes to math. This is another one down here where I have 1 goes to 5 and 1 goes to 4. 2 goes to 4 and 2 goes to 5. It doesn't necessarily matter that both 1 and 2 go to 4, but it does matter that I don't know what happens when I have x is 1. I don't know what happens when I have x is 2. So writing those out as data points, I have 1 for my x, and that can be 4 or 5. And so that's where, nope, you don't want it to be a question. So that's really what we're talking about when we're talking about functions, is a type of equation where every x has a designated y that it goes to. And most types of equations that we look at are that way. But we have to be able to determine which ones are and which ones aren't, so we know what kind of rules to apply to it. Right. So we're going to look at some examples of functions and non-functions. So in tables, you can't always tell 100% because you're not seeing the big picture. But we can tell from what we're seeing in this table, from this view, is it a function or not? So in this first table here, I have -1 gets me to 6. I also have 3 gets me to 6, and that's fine. Because again, I always know what's going to happen when x is -1. I always know what's going to happen when x is 3. This is a case where I have 2 goes to 3 and 2 goes to 3 again. And that's okay because, it's still always 2 goes to 3. Here, though, we have 2 goes to 3 and 2 goes to 5. So now we don't know. X is 2, but is the output, is it 3 or is it 5? And because we can't determine, that's unpredictable and not a function. Graphs, we have a little trick for making the same idea. So if you make a vertical line, that's the line that goes up and down, through a graph at any point, does it cross the graph more than one time? If it doesn't, if it's just one time, you have a function. If it's more than one time, you do not have a function. But it's the same reason why with the tables. So here, if I'm at, that looks like -2 maybe, x is -2, I always know the solution is going to be here, just above 3. Here, x is 2. I always know this solution is going to be here at +2 for y. But in these non-functions, what we see is, oh, well, here x is about 2, but I don't know if y is this positive 2.2 approximately or this negative 2.2. I don't know which solution we are supposed to look at. Same thing with this graph. It overlaps several times. So you don't know, given this x value, is this your y? Is this your y? Or is this your y? Which is exactly why in the previous unit, we only graphed the tops of the square root functions. Because if we graphed the bottom half, then we have too many y values. We don't know for every x which y it goes to. And that's why we always just graph the top of it. Unless you have a negative in front of it, then you graph the bottom. All right, so we're going to try that on some tables and some graphs. So first, with the graphs, these ones are super easy. We do what's called the vertical line test, like I was just saying. So I pick a point and I draw a vertical line. This crosses it one time. And so, yes, that is a function. Yes. Here, when I draw a vertical line, 1, 2, 3 times it crosses there. And so that is not a function. We don't know, given this x value that it lines up with, what the y value would be. So this would be no. And you always want to look for a point. Like I wouldn't draw the vertical line here because obviously that's only going to cross once, but I see a spot where it's going to cross multiple times. So you always want to see, is there a spot where that's going to happen? And go to that spot. So here I draw a vertical line. Again, that's just one time, so that's going to be yes. Vertical line, one time, yes. Here, a vertical line, again, it's not too steep at any point, so if you draw a vertical line, it's still just one point there. If you drew a horizontal line, it wouldn't, but that's not the rule. It's a vertical line. We're always talking about the x value because that's the main thing that is the input. That's the information we have. The y value is what we're always trying to find out. And so we always want to be able to find out the exact answer. So again, this is a yes. Now here, there's no graph over there and over there, so I'm going to focus on where the graph is. If I draw a vertical line through this, it has an infinite amount of points where it's crossing. It's crossing at every single point possible. And so that is not a function. That's literally all points on here. It's just, if you zoom in, there's more points between the points. You get into decimals, it's just points all the way down. All right, so now in tables, a good clue to look for is look in the x's and see if there's any repeats of x's. If there's no repeats of x's, you're probably fine. So here, there's no repeats of x values. Those are all different ones. And they all have different y values that they go with, or f of x values. So that would be, yes, that's good. Here, again, all the x values are different. That's a good sign. And I do see that there's some values that have the same y value. So 1 leads to 6 and 5 leads to 6. And again, that's okay because I always know what's going to happen at 1. I always know what's going to happen at 5. Same thing here. 2 leads to 3 and 4 leads to 3. That's okay because I always know what happens when I have an input of 2. I always know what happens when I have an input of 4. So this again would be yes. Now I have repeats of x's. And so I'm looking and I see, well, sometimes 3 gets me to 9, but sometimes 3 gets me to 10. So now I don't know. What does 3 give me? Sometimes 4 gets me to 11. Sometimes 4 gets me to 12. So again, I don't know. 5, sometimes it gets me to 13. Sometimes it gets me to 14. Again, I don't know. And so this is a situation where it's not a function. It's more statistics. You don't necessarily know what's going to happen when you have an input of 5. So this would be no. Down at the bottom here, we have a very similar table. You have repeats of 3s, repeats of 4s, repeats of 5s. But this time, 3 always gets you to 9. 3 always gets you to 9. 4 always gets you to 11. 5 always gets you to 13. So I always know what's going to happen from 3. 3 is always going to go to 9. 4 is always going to go to 11. 5 is always going to go to 13. So that would be a yes. So we see a lot of relationships are functions. And that's why we use the language almost interchangeably. We say function, we say equation, and a lot of times we mean the same thing. A function is a type of equation, just like an apple is a type of a fruit. It's just like it's a big type, right? Functions are a big type of equations that we talk a lot about. Right. So we're going to be solving functions, but the math that we're doing is the same math that we've done before. It's solving by simplifying and solving backwards using order of operations in reverse. So if you have a function, we use this f of x instead of y, but again, it means the same thing. The cool part about it, though, is that when we get into bigger and bigger functions, as you get into higher levels of math, this just helps you keep track of what you're plugging in. So it looks a lot tidier. It's more organized as we get into bigger levels of equations. So what you would do, if I wanted to solve for x equals -6, I'm putting in that -6 into this part here as x, but I'm not solving anything over there. That's like telling me you're plugging in -6 into this function. It's like a title. It's not a math part. Over here is our math part where we're plugging in -6 and we're simplifying. So you multiply, combine like terms, and we get -12. And so you would say that as f of negative 6 is equal to negative 12. So that's how we say that, f of. Now it sounds kind of funny, but that's what we say when it's in the parentheses, f of. I'll write that out, f, and then of is the word that we use, and that's the parentheses part. Now, when we are solving, when it says f of x equals, that means we replace all of f of x with that number, and then we solve for x. It's just like saying y equals this, and then you replace y. And then you're just using order of operations backwards, and when you get your solution, you plug that in where the x goes, so 83 is the x in this function, and the answer is 32.5. So it's just taking this and replacing your x with 83. So we're going to do an example of that together. And we will do this actually in class live as well. But videos are a good way where you can kind of go at your own pace, where you can pause things, take a break, write things down that you need to. So this is just, a different way of accessing a lot of the information we talk about in class. All right. So we have this function here, f of x equals 5x minus 15. We have one of the things we need to do is solve for x equals 8. So I'm going to take 8, and I'm going to be plugging that into the function. So everywhere there's an x, I'm going to be putting in 8. All right, so I'm going to change over this color here. And now I'm going to be putting in this 8. And again, over here, it's just like it's a placeholder. It tells us what we plugged in. And then I need to erase that. I meant to put a parentheses there. Here we're going to plug in the 8, and this is the part where we're actually going to do our math. So we're going to use PEMDAS. We're simplifying. So anytime you're simplifying, you're not moving things around on an equal sign. You're just making things more simple. We're using order of operations. So using PEMDAS, first up is I can do multiplication, and that's before I can do subtraction. So first I'm going to do 5 times 8. That makes 40. And then I still have that minus 15. And 40 minus 15 is 25. So I would say f of negative 8 is equal, or positive 8, sorry, is equal to 25. Now we're going to solve when we know what f of x is. So this time, what I'm going to be doing is I'm going to be replacing all of f of x. And then the rest of the equation stays. And this time, since we're going to have to be moving things around the equal sign, we're going to be solving. And so that's going through order of operations backwards. So first, I can undo any addition or subtraction. So add 15. Add 15. I know my handwriting's not beautiful on here. All right, negative 35 plus 15. And it's okay to use a calculator. Negatives can be kind of tricky when you're adding positives. But that makes it more towards positives. That makes negative 20. And then we still have our 5x. And now we can get rid of multiplication or division. So you can get rid of the times by 5 by dividing by 5. Negative 20 divided by 5 is negative 4. And then we have our x there. And so now we can write that in function notation. Our x is going to be that negative 4. And so I write that exactly that way. F, and you can use positive, or sorry, you can use capital letters or lowercase letters for the F and the X. I kind of switch between. I don't know if there's a preferred, I don't know, whatever. And then we'll have our negative 35. So that says f of negative 4 is negative 35. So that's how we're solving these things. It's math that you've done, throughout Algebra 1, 2, and through the beginning of this year. It's not new math. It's just applying it to a new situation. So the next thing that we are doing is inverses. This will be the last thing for the video. And again, math that you've done before, but just in a new situation. So an inverse equation is one where you get opposite x and y values, which is helpful in a lot of ways. A lot of times you have to reverse a process and know what, given what you got out, what did you get in? And so this is actually really helpful in a lot of real world situations. So we're going to do that today. So when you are finding an inverse equation, the steps are pretty simple. So I usually like to use y instead of f of x. It's just easier when you're moving it around, so it's not so many letters. So I'm going to just use y instead of f of x here. But it means the same thing in this context. Like, we're not messing with anything by changing it to a y. It's just easier on the eyes, I guess. If you want to stick with using the f of x here, that's fine. All right. So the idea of inverse equations is a flipped x and y. And so that's exactly what we do here. We're going to take the x and the y and flip them. So I'm going to put the x over here. So that's going to go over here. Still going to have our equal sign. And then it's going to be 5y minus 15. And so that's the inverse relationship. But we don't graph equations in x equals form. We have to graph them in y equals form. So what we're going to do is manipulate this so that it's actually in y equals form. And again, these are going to be steps that you've done in math before. To get y all alone, we're going to use order of operations backwards. So first, I have to get rid of any addition or subtraction. To get rid of minus 15, I plus 15. So that cancels this out. Over here, that doesn't make 15x. That's still x plus 15. It didn't get multiplied, it's added. Now we have to still get y all alone, but it's being multiplied by 5. So we have to divide everything by 5. So when you multiply or divide in an equation like this, you want to make sure you're doing every single thing. So I'm going to divide by 5 here, but everything gets divided by 5. So when you are dividing x by a number, a good way to think about it is that's really a 1x. So you can do 1 divided by 5, which is 0.2. And then we still have our x on there. So that's a trick anytime you're trying to simplify that out of a fraction. Show that it's a 1x, and then you can just do 1 divided by whatever that number is on bottom, and then you get a decimal. So then we have 15 divided by 5, which is 3. And here the 5s cancel out, so we get y. And so that's the inverse function there. And of course, we can then write that in function notation. So that's f of x instead of y equals 0.2x plus 3. And so this is going to be a function that gives opposite x and y values to our original function. And we're going to see that in a moment. So we're going to look at this graph I made. So I have the original function here, f of x equals 5x minus 15. And then I'm just using g of x here so that we can kind of separate them. We do that a lot of times in math, like we're function, like f is the main one, but we just use lots of different letters so that we can, you know, have different ones. But the idea is the same. So this would be g of x, but it's still a function. And so the cool thing about these, one way that you can really easily check if it's inverses of each other is what they do is they are mirror images of each other over this line y equals x. So we have this line y equals x here. And if you were to put a mirror along that line, you would see the same thing on both sides. And that's like kind of just a cool check that you can do to see if two things are inverses. We also see other ways of finding out if two things are inverses. We can look at the tables. So here's the table for our original function, 5x minus 15. At -1, I get -20, 0, -15, and so on. Here's the table for the inverse function. And look at how it switches these values. Here, when x was -1, y was -20. Here, when x is -20, y is -1. It just flips those opposite. So again, that's how you can tell that this is an inverse function. It's going to have opposite x and y values, which is the definition of inverse functions. And a cool feature is that they reflect over this line, y equals x. They make a mirror image. All right, so back over here. But we don't always have a way to get the table like that or get a graph. And the graph and the table, it's not always 100% complete. You're not seeing the full picture. And so you can never be 100% certain. So there is another way to check if two things are inverses, and it's actually kind of cool. So you're going to go to the next page here. It's called composite functions, and it's where you can take one function and put it into another. And the cool thing about inverse functions is that when you do this, you'll always get 1x or x. So we're going to try that with the original function we have and the inverse function that we just made. And we're calling that g of x just to make this process simpler. And there's another example, two examples up here, one that has a quadratic and a square root, one that is linear like this. But again, we're just going to go through this example together. So if I wanted to do f of g of x, which is a composite function, meaning I'm putting one into the other, I'm taking this part here, 5x minus 15. I don't have a purple, that's too bad. And instead of the x, I'm going to be plugging in the other function. So I'm going to take this x, and that's what's going to get replaced with this over here. So I'm going to simplify. So I can distribute my 5 there. 5 times 0.2 is 1. 5 times 3 is 15. And then I still have this minus 15 here. Well, plus 15 and minus 15, those cancel out. So I'm just left with 1x. So f of g of x equals 1x. We can also try it the other way around, and it should do the same thing. They'll undo each other's steps because they're the opposite functions. So when you put them together, they just undo each other, and you're left with just x. So we're going to do the same thing here. We're starting with the g of x. G is on the outside, so that's the main thing. And where the x is, that's where I'm going to be plugging in the other function and see if it works this way as well. So I'm going to be putting in the 5x minus 15. I'm going to distribute that 0.2 through the parentheses. 0.2 times 5 is 1x. So there's the x there, so 1x. 0.2 times negative 15, and you can definitely use a calculator, because I know a lot of you guys would be like, what's 0.2 times negative 15? I have an old calculator. This is not one of the school ones, but it's similar. You can see. No, there we go. Negative 3. You can also use the Desmos calculators, right? So that would be minus 3, but we still have our plus 3 here. So again, you have a situation, those cancel out, and you're just left with 1x. And so that proves that these are inverse functions. All right, so I know that was a lot of information today. We talked about what is a function. And again, that's just every x has one y that it goes with. We talked about how to solve functions. So just plugging things in, simplifying or solving. And we talked about inverse functions, which is where the x and the y are opposite. And we can look at lots of different ways to see that that's true. So those are all the topics for today. I look forward to this week where we will be practicing more of this. Have a lovely day. I'm gonna end the video. It's always this awkward moment where I have to, it takes me longer than I expect it to, so it's always awkward. All right, now it's done.